Hello viewers, how are you? I welcome you on my channel. Today we are going to discuss a chapter from class 9 which is polynomial, and in this video we will discuss how to find the zero of a polynomial, what is the degree of polynomial, remainder theorem, and this is in your book NCERT class 9th second chapter. I hope you are enjoying the videos and you find the videos helpful. So let us see. In this video we will discuss what is a polynomial. As in my previous video for 10th class, you must have got many things about the polynomials, but in this video we will discuss the topics of the 9th standard only, in which the first thing is how to identify which one is a polynomial and which one is not, which I have discussed in 10th class also. There are two conditions. First is the power of the variable should not be negative, and second is the power of variable should not be fraction. If any of the polynomial fulfill both the conditions, then it will be polynomial. We will discuss few aspects of the polynomials. Degree of a polynomial, the highest power of variable is called the degree of polynomial. For example, px is equals to 3x cube plus 2x square plus 3. In this you can see the highest power is 3. So here highest power is equals to 3. Therefore degree is equals to 3. One more example. This was example 1. Example 2. Px is equals to 2x plus 1. In this there is no power, so we understand there is a 1, so degree is equals to 1. Next thing is how to find the coefficient of particular term in the polynomial. So coefficient means it is a number multiplied with each term respectively. Actually, it is the number multiplied with the each term of variable. You must have studied the same thing in the 8th class also. For example, px is equals to 3x square plus 2, and we have the question find coefficient of x square. Then solution coefficient, because in the solution of px we have 3x square plus 2. And you can see 3 is multiplied with x square, therefore coefficient of x square is equals to 3. Like this you can find the coefficient of any number. So let's take another example of the same. Find coefficient of x square in the following. First 3x plus 2, second 2x cube plus x square. The solution of first part, px is equals to 3x plus 2. As you can see in our question, we need to find the coefficient of x square, but there is nowhere any x square term. So what we will do, we'll write this like this: 0 into x square will make it 0, 3x plus 2. Therefore coefficient of x square is 0. Second part you can see. So this is here, you may take it qx, another 2x cube plus x square. You can see x square written, but nothing is written with this. So how to find the coefficient? We just write the polynomial in the form 2x cube plus 1 into x square. Therefore coefficient of x square is equals to 1. So this is the way you can find the coefficient of any term in the polynomial. Here I have done for x square. You can do this same thing for x as well as x cube and whatever they are asking in the question, depending upon the question. Now let us move to the new thing. After the coefficient, now we will learn what are the zeros of a polynomial. So zeros means we need to find such a value of variable which makes the whole polynomial 0 or the expression 0. Here we can take an example. It is the value of variable which reduce the polynomial to 0. For example, px is equals to 2x square plus 5x plus 3. You are given this polynomial and we need to find a 0 of suppose I have given some number and x is equals to minus 1. So we need to check whether x is equals to minus 1 is 0 of this or not. So what are we going to do? हम क्या करने वाले हैं? x की जगह पे ये minus 1 लिखना होगा सब जगह. Therefore p minus 1 is equals to 2 into minus 1 square plus 5 minus 1 plus 3. And let us check what answer comes. 2 minus 1 square will be 1 and this will be plus 5 into minus 1 minus 5 plus 3. So we get 2 minus 5 plus 3. 5 minus 5 is equals to 0. Therefore p minus 1 is equals to 0. Hence x is equals to minus 1 is a 0 of px. This is the way that we can check whether something is 0 or not. Let me put another value for x and we'll check whether this is 0 or not. The second value is 2. I'll check for this value whether this is 0 or not. Now let us check for this 2 also whether this 2 is a 0 of this polynomial or not. We will see here p2 is equals to 2 into 2 square plus 5 into 2 plus 3. So we get 2 into square of 2 will be 4 plus 5 is a 10 plus 3. So we get 2 4 is 8 plus 10 plus 3 and we have 8 3 11 10 21 which is not equal to 0. Therefore x is equals to 2 is not a 0 of px. So this is the way we can check whether the given number is a 0 of the polynomial or not. If the answer by putting the number in place of variable comes 0, then we can say the given number was the 0, otherwise it is not a 0. So in this case we can see this 2 is not a 0 and the previous case we have seen this minus 1 was a 0 of this polynomial. Hope this is clear. Now we'll move to the next topic. So just now we have learned how to check whether the given number is a 0 of a given polynomial. But sometimes we come across to the question in which we need to find the zeros of the given polynomial. So how can we find the 0 of a polynomial? This is very simple. Whatever the polynomial is given to you, जो भी polynomial आपको दिया गया है उसको हम 0 के इक्वल लिख के सॉल्व करके वेरिएबल की वैल्यू निकालते हैं. जो भी वैल्यू आएगी वही 0 होगा. तो यहाँ पर हम कुछ एग्जांपल ले लेते हैं और उससे पता चलता है कि 0 हम कैसे निकालते हैं. Let px is equals to x plus 5. Find 0 of px. They have given this. Their solution. What are we going to do? Let px is equals to 0. Therefore, x plus 5 is equals to 0. And we'll take this 5 to the right hand side. So x comes minus 5. Here 0 of x plus 5 is minus 5. So like this we can find the 0 of any given polynomial. We will take one more example. Example 2. Find 0 of px is equals to ax. We need to find 0 of this. So it's quite simple. We'll write px is equals to 0. Therefore ax is equals to 0 and we need to find the value of x. Then x is equals to 0 upon a. Finally we get x is equals to 0. So x is equals to 0 is the 0 of this given polynomial. So likewise we can do this type of questions, how to find the 0 of the any given polynomial. Basically in the 9th class they are going to give you linear polynomial. So before moving what is linear, you have gone to my previous video in which we have discussed if the degree is 1 then it will be linear, if the degree is 2 it will be quadratic, and if the degree is 3 then it will be cubic. Now we are going to discuss the remainder theorem. But before moving to the remainder theorem, we should know what is a remainder. You know very well, when we divide any dividend with the divisor, and if the divisor is not the factor of the dividend, then we have some remainder. So same thing is in this polynomial also. Here you can see an example. Divide px by gx, where px is equals to x plus 3x square plus 1 and gx is equals to 1 plus x. How we will divide this? Let us see first. Solution. Here the first step is we need to write these polynomials in the descending order of power of variable. Therefore px is equals to 3x square plus x plus 1 and gx is equals to x plus 1. Now we need to divide. So in this part we will divide px divided by gx. Now let us see this here in the top. So px is 3x square plus x plus 1 and we need to divide by x plus 1. So see, when we start divide, we check this number with this number. We need to get this 3x square from this by multiplying some number. So actually 1 is there and we need 3. So 3 ones are 3. We write 3 here. 3 ones are 3 and x also we need. It will be x square. Now we multiply this 3x with 1 plus 3x. Then we need to subtract. फिर हम minus करेंगे. Now you can see this is 3x square and this is also 3x square. On subtracting they will cancel out. So we get 0 here. And this is minus 3x because previous sign is vanished now. We will take the new sign. Okay, minus 3 plus 1. It will be minus 2x and plus 1. So 0 is nowhere valid here. Now the next term we need minus 2x and x is already there. So we need to put this sign also here. So we have minus 2 x and 2 ones are minus 2 here. Again we'll change the sign. It will be plus. They will cancel out and we get 3. So here you can see remainder is equals to 3. So this remainder is find out by the long division method, exactly dividing. But without exact divide, we can also find the remainder, and that is in the remainder theorem only. And let us see what is the remainder theorem now. Now after this division, we will see what is the remainder theorem. Remainder theorem actually, let px be any polynomial of degree greater than 1. So you can see this is the px where degree is 2. Greater than 1 or equal 1, both the things are there. And let a be any real number if px is divided by linear polynomial x minus a, because it is 0, so x is equals to a will be there. We have taken already a. Then remainder is pa. So this remainder can be calculated with the help of this theorem also. Now let us see how the remainder theorem is used in this question. Now we will do the same question which we have done just now with the help of the remainder theorem. So here px is 3x square plus x plus 1 and gx is x plus 1. Actually x plus 1 is equals to 0, so we can take x is equals to minus 1. And in the previous section you know very well how to find 0. So px is equals to 3x square plus x plus 1 and gx is a 0, then x plus 1 is equals to 0, x is equals to minus 1. Now we need to find the remainder. So p minus 1 is equals to 3 into minus 1 square plus minus 1 plus 1. So we get 3 because minus square plus minus 1 plus 1. 1 will get cancelled and this will be 3. So this is the remainder. You know very well, earlier also we got the same remainder. So without division also we can find the remainder when a polynomial divides the another one. Here you can see in the earlier division also we get the remainder same when we divided this px with gx. Here also, but we have used the remainder theorem. So this is the remainder theorem. If remainder comes 0, then we can say this gx is a factor of this. Okay, now we'll take some examples how to use this remainder theorem. So now after learning remainder theorem, we have some questions from a book. Exercise 2.3, question number first. Find the remainder when this is divided by this, this and this. In this we will use the remainder theorem, and the questions are very simple. Here is the solution of this first part. Let x plus 1 is equals to 0. Therefore x is equals to minus 1. Now p minus 1 is equals to minus 1 cube plus 3 minus 1 square plus 3 minus 1 and finally plus 1. So you can see minus 1 cube is equals to minus 1 square plus 1, so it's a 3 minus 3 and this plus 1. 3 will get cancelled and 1 will get cancelled with this. So finally we got 0. Therefore remainder is equals to 0 when px is divided by x plus 1. Now let us move to this second part. Here second part, x minus half is equals to 0. Therefore x is equals to half. Now p half is equals to half cube plus 3 half square plus 3 into half plus 1. So we get 1 upon 8 plus 3 upon 2 to the 4 plus 3 upon 2 plus 1. So take LCM. LCM will be 8. 1 plus 6 plus 12 plus 8 is equals to 27 upon 8 is equals to remainder. Now we move to this fourth part, x plus pi. We need to find the remainder when x plus pi divides this. This is also the same question which we have done earlier. Here x plus pi is equals to 0. Therefore you can say x is equals to minus pi. Now we need to find the remainder is equals to p minus pi. So wherever x is written, we need to write the pi. It will be minus pi whole cube plus 3 minus pi square plus 3 minus pi plus 1. So this will be minus pi cube plus 3 pi square minus 3 pi plus 1. So this is the remainder. So like this you can find the remainder of any polynomial when it is divided by another polynomial. So in this video this much only. For the next topics, watch my next video. Hope you enjoy this video. If you find it useful, press like and subscribe my channel.